Hello, in this lecture we find out the value of x. In the drawing we have a quarter circle, AFE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment BE that is equals to 12 units in its length. This is angle DGC. This is equal to, this is actually angle GDC. This is equals to theta, and this is angle EDC. This is also equals to theta, and our mission is to find out the length of this line segment GD. This is equal to x. So first of all, we know that ABCD is a square, therefore all the four angles inside square ABCD are right angles. So this angle equals to 90 degrees in its size. This angle is also a right angle. This angle equals to 90 degrees. And finally, this angle is also equals to 90 degrees in its size. In addition, we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to side AB. So I write it down. Side DC is parallel to the opposite side AB. DC is parallel to AB, but AB is part of the straight line AE and is parallel to DC. And know that if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, the straight line AE itself must be also parallel to DC. Okay, so I write it down. The straight line AE must be also parallel to DC. And again, AE is parallel to the opposite side, DC. Okay. You can actually implement in this drawing rule 15. I'll repeat quickly rule 15. Moving to rule 15. Alternating angles between parallel lines are equal to each other. So we have in the drawing line A is parallel to line B. Again, line A is parallel to line B, and those two angles, they are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, alpha equals to beta. We can actually implement rule 15 in our drawing. Why? Because in our drawing, those two angles are defined as alternating angles. So this is angle AED, and this angle is angle EDC. They are both alternating angles, and they are located between the parallel lines BC and AE. Again, DC is parallel to AE, and therefore, according to rule 15, they are equal to each other. Okay, so I write it down. Angle EDC is equal to this angle, angle AED. But this is angle EDC, and it is equals to theta, according to what is given to the question. So we can write here that EDC equals to theta, and from this equation, theta equals to EDC equals to AED. We will derive that angle AED is also equals to theta. So this is angle AED, and it is also equals to theta, according to rule 15. Again, angle EDC equals to angle AED, according to rule 15. So, in the next step, we'll do a construction, that is to say from point G, we'll do perpendicular on AB. Again, from point G, we'll do perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point between the perpendicular GN and side DC of the square as M. By doing this construction, we actually created here quadrilateral DMNA. Inside this quadrilateral DMNA, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus this missing fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral DMAN is 250 to 360 degrees, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral DMAN we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral DMAN as a rectangle. So write it down. Quadrilateral DMAN is a rectangle. Why? Because it has 4 right angles. Okay. GN is perpendicular on AB. So GN is a perpendicular, it is absolutely a straight line. Again, GN is a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle plus this missing angle. In total, the sum of those 2 angles must be equal to 180 degrees according to rule 3 actually. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the left side of the straight line GN at point M 280 degrees, this missing angle, actually angle GMD, must be equal to 90 degrees in its size. In the next step, I will copy this right triangle GMD in a new page and we will analyze it. The hypotenuse GD of the right triangle GDM equals to x according to what is given us the question. So this is the right triangle GMD that I copied from the original drawing. From the drawing it is very easy to see that cosine theta equals to dm over gd. So cosine theta equals to dm is the missing side, so we leave this it is, over gd. Gd is x, according to what is given as the question, so we substitute gd by x. So in conclusion, I should found out that according to equation 1, cosine theta equals to dm over x. So here we multiply this equation 1 by x, and finally we get that according to equation 1, dm equals to x times cosine theta. In the next step, I'll copy the right triangle ADE in the new page and we'll analyze it. But before that, we'll define one side of this square ABCD as y. Therefore, AD equals to y. Side AB of square ABCD equals to y. According to our definition, side BC also equals to y, of course. And finally, side DC of square ABCD must be also equal to y. So now I'll copy this right triangle ADE in the new page and we will analyze this right triangle ADE. Side AD of triangle ADE equals to y, according to our definition. It is one side of square ABCD. What is the definition of side AE of the right triangle ADE? AE, from the drawing, it is very easy to see that point A is the quarter in the center of the quarter circle, and point E is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as R, and therefore AE equals to R. And finally, DE equals to 12. The hypotenuse DE of the right triangle ADE equals to 12 units in its length, according to what is given us the question. So actually, this is the right triangle ADE, the copy from the original drawing, and here, this is angle theta, of course. In this right triangle ADE, it is very easy to see that cosine theta, this will be equation 2, cosine theta equals to AE over DE. Again, in the right triangle ADE, cosine theta equals to AE over DE. AE is R and DE is 12. DE is 12. So in total, according to equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2. While according to equation 1, we have already found out that the dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1, by R over 12 from equation 2. We'll do it now, and we get that according to equation 1, dm equals to x times cosine theta. Cosine theta is R over 12. So if we actually found out that dm equals to xr over 12, dm equals to xr over 12. This is sine dm that equals to xr over 12. But we already found out that this quadrangle dm an is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle dm side dm must be equal to the opposite side an, but dm equals to xr over 12, therefore an must be also equal to xr over 12. Okay. Likewise, according to the same rule, in the same rectangle dman, the side dA must be equal to the opposite side mn, but dA equals to y, therefore mn must be also equal to y. In the next step, I'll copy the right small target DGM. In the new page, we'll continue to analyze this right small target DGM. So actually, this is the right target DGM, the copy from the original drawing. In this right target DGM, it is very easy to see that sinus theta equals to GM over GD. Again, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is, over GD. GD is x, therefore we substitute GD by x. So we found out that according to equation 1, sinus theta equals to GM over x. Here we multiply this equation 1 by x, and finally we get that GM, according to equation 1, GM equals to x times sinus theta. In the next step, I'll copy the right triangle, this right triangle ADE again in this new page. we will continue to analyze this right triangle, triangle ADE. So actually, this is the right triangle, triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Sinus theta equals to AD over DE. So sinus theta equals to AD is y and DE is 12. So in total I actually found out that according to equation 2, sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, complete it again, sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, we have already found out that Gm equals to x times sinus theta. So we have those two equations. Now we can substitute sinus theta in this equation, equation 1, by y over 12 from equation 2. We'll do it now and we get that Gm equals to x, and sinus theta according to equation 2 is y over 12. So in total, Gm equals to xy over 12. So actually, this is side Gm, that is equals to xy over 12. In the next step, we'll join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R according to our definition. AG equals to R. By joining points A and G together by a straight line, we created the right triangle, triangle AGN. So we copy this right triangle AGN in a new page, and we will implement on this right triangle AGN the Pythagoras theorem. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to sum of the squares of the perpendiculars. So actually, this is the right triangle AGN that I copied from the original drawing. We already found out that the hypotenuse AG equals to R. We already found out that side AN equals to XR over 12. What is the length of side GN? Here, from the drawings, it's very easy to see that GN in total equals to GM plus MN. So GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. So I write it down. This is side GN. That is equals to XY over 12 plus Y. So in this right triangle triangle AGN, according to the Pythagoras theorem, AG squared is equal to AN squared plus GN squared. This is according to equation 1. AG is R, therefore AG squared is R squared. And it must be equal to AN squared. AN is XR over 12, therefore AN squared is XR over 12 squared. XR over 12 squared equals to X squared times R squared over 12 squared, that is 144. So in total, XR over 12 squared equals to X squared times R squared over 144 plus GN squared. GN equals to XY over 12 plus Y, therefore GN squared equals to XY over 12 plus Y squared. So according to equation 1, R squared equals to X squared times R squared over 144 plus, here we take Y, we take out Y as a common factor from this expression. So Y was taken as a common factor. What is left from xy over 12 after we took from it Y as a common factor? What is left is actually x over 12. And we have here Y. So what is left from Y after we took from it Y as a common factor? What is left is actually 1. All squared. So according to equation 1, we should find out that R squared equals to X squared times R squared over 144 plus, so here we have this expression. The value of this expression, according to the algebraic identity, that A times B to the power of M equals to A to the power of M times B to the power of M. So according to this algebraic identity, we get that Y times x over 12 plus 1 squared will be equal to Y squared times x over 12 plus 1 squared. Okay. In the next step, we will multiply 1 by 12 and then we divide it by 12 in order to account factor with x over 12. And we get that according to equation 1, R squared equals to x squared times R squared over 144 plus y squared. So here we multiplied 1 by 12, so in total in the numerator we'll have here x plus 12 divided by 12 square. So in total this expression will be equal to x plus 12 over 12 square. Repeat again, this expression will be equal to x plus 12 square over 12, x plus 12 over 12 square. So if we found out that according to equation 1, r square equals to x squared times r squared over 144 plus y squared, and here we have the algebraic identity that says that a over b to the power of m equals to a to the power of m times b to the power of m. According to this algebraic identity, x plus 12 over 12 squared will be equal to x plus 12 squared over 12 squared, that is 144. So according to this algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m, x plus 12 over 12 square will be equal to x plus 12 square over 12 square, that is 144. Okay, this is according to equation 2, to equation 1. In the next step, we will join points A and C together by straight line. Okay, again, we will join points A and C together by straight line. I repeat again, we join points A and C together by straight line. Well, what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R, according to our definition. So, by doing this construction, by joining points A and C, we actually created the right triangle, triangle ABC. So copy this right triangle, triangle ABC in a new page, and we will implement on this right triangle, triangle ABC the Pythagoras theorem. Here by PT is a prevention from Pythagoras theorem. side AB of the right triangle ABC equals to y, and side BC also equals to y. Both those two sides and they are also the sides of square ABCD, and therefore each of them is equal to y. Here BC equals to y according to our definition. So actually, this is the right triangle ABC that I go from the original drawing. In this right triangle ABC, according to the Pythagoras theorem, this will be equation 2. AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it equals to AB square. AB is Y, therefore AB square is Y square, plus BC square. BC is also Y, therefore BC square is Y square. So in conclusion, we found out that according to equation 2, R square equals to 2Y square. Repeat again, according to equation 2, we actually found out that R square equals to 2Y square. This is according to equation 2. Well, according to equation 1, we have already found out that R square equals to X square times R square over 144 plus Y square times X plus 12 square divided by 144. So we have here two equations. Now we can substitute R square in this equation 1, by 2y square from equation 2. Repeat again. We will substitute R square in this equation 1, by 2y square from equation 2. And we get that according to equation 1, R square is 2y square, and it is equal to X square, and again here we have R square, that is 2y square over 144 plus y square times X plus 12 squared divided by 144. So here we multiply this equation 1 by 144, and I get that according to equation 1, two y square times 144 is 288 y square. Here we have y square in the denominator, so y square will get cancelled. We left only with 2x square y square, plus here we have also 144 in the denominator of this expression, so 144 will also get cancelled, and we left only with y square times x plus 12 square. So here we divide this equation 1 by y square, and we get that according to this equation 1, we have 288 y square, where y square is 288, Here y square will get cancelled, and we left only with 2x squared, plus here also y square will get cancelled, and we left only with x plus 12 squared. So here we will open the brackets of this expression, and we get that according to equation 1, 288 equals to 2x squared plus x plus 12 squared, x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So according to equation 1, I can find out that 288 equals to 2x squared plus x, 2x squared plus x squared equals to 3x squared plus 24x plus 144. So here we subtract 288 from this equation, equation 1, and we get that according to equation 1, in this side of the equation we have nothing, that is to say 0. On the other side of the equation we have here 3x squared plus 24x, and we have here 144 minus 288 equals to minus 144. According to equation 1, we can find out that 0 equals to 3x squared plus 24x minus 144. Here we divide this equation 1 by 3. And finally we get that according to equation 1, 3x squared over 3 is x squared, plus 24x over 3 is 8x, and here we have minus 144 over 3 is minus 48, this equals to 0. So according to equation 1, we can find out that x squared plus 8x minus 48 equals to 0. So actually, this equation is a quadratic equation, and we know that the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, here the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So in the next step, we put the values of a, b, and c, those values that we found from our specific quadratic equation x squared plus 8x plus 48 inside this general formula for x, in order to find out the value or the values of x in our specific quadratic equation. We do it now, and we get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a, so it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, so minus 4 times minus 48 equals to plus 192. So inside the root we have 64 plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus, and we have inside the root 64 plus 192 is 256, so we left only with 256 inside the root divided by 2. So actually found out that x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12, but x can never be equal to minus 12. Why? Because of the fact that x is the length of this line segment GD, and as x is a length, it must be a positive number. So the negative solution, x equals to minus 12, is incorrect. We cancel this solution. So, and we will take into account only the positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we found out that x equals to 4 units in its length. Repeat again that x is the length of this line segment GD. So the length of line segment GD that's equal to x is equal to 4 units. And that is the answer to the question. Repeat again, x GD is equal to x is equal to 4 units in its length. So in the next step, I'll summarize the lecture. In this lecture, I found out the length of this line segment GD that's equal to x. We found out the value of x. So, in the drawing, we have a quarter circle AFE. This is a quarter circle. Inside this quarter circle, we have square ABCD. In addition, we know that this is line segment DE that is equal to 12 units in its length. This is angle EDC that is equal to theta, and this is angle GDC that is also equal to theta, and our mission is to find out the length of this line segment GD that's equal to x. We have to find out the value of x. Okay, so first of all, we know that ABCD is a square, and therefore we know that all the angles inside a square are right angles, so those 4 angles inside square ABCD, they are all right angles. That is to say, they are equal to 90 degrees on their sizes, each of them. In addition, we know that the opposite sides of any square are parallel to each other. Again, the opposite sides of any square are parallel to each other, and especially it is true in square ABCD. So in square ABCD, side DC is parallel to side AB. DC is parallel to AB, but we know that here we have AB, side AB is part of the straight line AE. Again, side AB is part of the straight line AE and is parallel to DC. And you know that if a part of a straight line is parallel to another straight line, then the straight line itself, AE, must be also parallel to DC. And therefore, AE is also parallel to DC. Repeat again, AE is also parallel to DC. So here we can implement rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. Again, alternating angles between parallel lines are equal to each other. So in the drawing we have, this is line A that is parallel to line B. And we have those two angles that are defined as alternating angles and they are located between the parallel lines A and B. Okay, and therefore they are equal to each other. That is to say, alpha equals to beta. We can actually implement rule 15 in our drawing. Why? Because in our drawing we have those two angles that are defined as alternating angles. Again, this is angle EDC and this is an angle AED. Those two angles EDC and AED, they are defined as alternating angles and they are located between the parallel lines DC and AE. Again, we have already found out that DC is parallel to AE. And therefore, according to rule 15, they are equal to each other. So those two angles are equal to each other according to rule 15. Because there are alternating angles that are located between the parallel lines DC and AE and therefore they are equal to each other. So here, I want here that angle EDC equals to angle AED according to rule 15 because those two angles are alternating angles and they are located between the parallel lines DC and AE. But this is angle EDC is equal to theta, according to what is given as the equation. So we can write here that angle EDC equals to theta. And from this equation, theta equals to EDC equals to AED, we derive that angle AED also equals to theta. So this is angle AED that is also equals to theta. Okay. So in the next step, we did a construction. That is to say, from point G, we draw perpendicular on AB. Again, from point G, this is point G. From this point, point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. So this is point N. Likewise, we define the intersection point of the perpendicular GN with side DC as M. This is point M. By doing this construction, get the quadrilateral DM and A. This is quadrilateral DM and A. Inside this quadrilateral DM and A, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. Okay, so inside this quadrilateral DMNA we have 4 right angles. Any quadrilateral that has 4 right angles must be a rectangle if not a square. So we went to this quadrilateral DMNA as a rectangle. Okay. So we know that according to our construction, GN is a perpendicular because from point G we draw perpendicular on AB. So GN is a perpendicular. So GN is a perpendicular, it is absolutely straight line. So we know that GN is a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the areas must be equal to 180 degrees according to the rule that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have at the left side of GM, the left side of GN, this is the straight line GN, which areas we have at the left side of the straight line GN at point M. We have this angle, that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. And therefore, this missing angle must be equal to 90 degrees in its size. And therefore, the small triangle GMD is a right angle. So, copy this right angle GMD in the new page and we analyze this right angle triangle GMD. So, actually, this is the right triangle GMD that I copied from the original drawing. The hypotenuse GD equals to x according to what is given as a question. And this is angle theta. So in this right angle GMD, it is very easy to see that cosine theta equals to dm over GD. Again, cosine theta equals to dm over GD. dm is the missing side, so we leave it as it is. Over GD. GD is x, so substitute GD by x. So in total, we can find out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. Okay, dm equals to x times cosine theta. This is according to equation 1. In the next step, I actually copied this right angle triangle ADE in a new page, and we analyze this right angle triangle ADE, but before that we defined one side of this square ABCD of SY, and therefore all the four sides of square ABCD, they are equal to y. AD equals to AB equals to BC equals to DC equals to y. And what is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and ends at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. And finally, the hypotenuse DE equals to 12, according to what is given as the question. So actually, this is right triangle ADE that I covered from the original drawing. This right triangle ADE, in this right triangle ADE, cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is R, DE is 12, so in total cosine theta equals to R over 12. This is according to equation 2. Again, according to equation 2, cosine theta equals to R over 12, while according to equation 1, we have already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1, by R over 12 from equation 2. We did it and found out actually that according to equation 1, dm equals to x times cosine theta. And cosine theta is R over 12. So in total, we actually found out that according to equation 1, dm equals to xr over 12. So here, this is side dm that is equals to xr over 12. We already found out that this quadrangle dm an is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle dm an are equal to each other. That is to say, side dm equals to the opposite side an. dm equals to an. But dm equals to x over 12, therefore an must be also equal to xr over 12. Likewise, according to the same rule in the same rectangle dm an, side dA must be equal to the opposite side mn. Again, dA equals to the opposite side mn, but dA equals to y, therefore mn must be also equal to y. Okay? So actually, In the next step, copy the right triangle GDM in a new page and continue to analyze this right triangle GDM. So actually, this is the right triangle GDM that I copied from the original drawing. In this right triangle GDM, it is very easy to see that sinus theta equals to GM over GD. Again, sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is, over GD. GD is X, so we substitute GD by X. So in total, we found out that sinus theta equals to GM over X, according to equation 1. Here, multiply this equation 1 by X, and finally found out that GM equals to X times sinus theta. This is according to equation 1. In the next step, actually copied the right triangle ADE in this new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. This right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Again, sinus theta equals to AD over DE. AD is Y, because we defined one side of square ABCD as Y, and therefore all the four sides of square ABCD are equal to Y. So AD is Y, DE is 12 according to what is given as the question. So in total, actually found out that sinus theta equals to Y over 12. According to equation 2, sinus theta equals to Y over 12. This is according to equation 2, while according to equation 1, we have already found out that the GM equals to X times sinus theta. So now we can substitute sinus theta in this equation 1, by Y over 12 from this equation 2. We did it and found out actually that GM equals to X times sinus theta, and sinus theta is Y over 12, and therefore in total we found out that GM equals to XY over 12. So this is side GM, and it is equals to XY over 12. In the next step, we join points A and G together by side line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the closest circle, and ends at point G, that is the point of the closest circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this closest circle, that is equal to R. So by joining points A and G, we get the right triangle AGN. So copy the right triangle AGN in your page, and we implemented the Pythagoras theorem in this right triangle AGN. The hypotenuse AG is R, AN equals to X R over 12, and side GN in total equals to GM plus MN. That is to say, GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. Repeat again. GN in total equals to XY over 12 plus Y, AN equals to XR over 12, and the hypotenuse AR equals to, the hypotenuse AG equals to R. In this right triangle AGN, according to the Pythagoras theorem, AG square equals to AN square plus AG square equals to AN square plus NG square. Again, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square equals to XR over 12 squared. That is actually XR over 12 squared equals to X squared times R squared over 12 squared, that is 144. So in total, XR over 12 squared equals to X squared times R squared over 144 plus GN squared. GN is XY over 12 plus Y, therefore GN squared is XY over 12 plus Y squared. So according to equation 1, we actually found out that R squared equals to X squared times R squared over 144. So here we took Y as a common factor from this expression. So we took Y as a common factor. So what is left from XY over 12, we took for it Y as a common factor. What is left is actually X over 12. Plus here we have Y, so We took y as a common factor, so what is left from y after we took from it y as a common factor? What is left? It's actually 1. All squared. So here we have the algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m. According to this algebraic identity, we will get that y times x over 12 plus 1 squared will be equal to y squared times x over 12 plus 1 squared. Okay? This is according to this algebraic identity. And we have to edit, we actually copy this expression here, x squared times r squared over 44, that is equal to r squared according to equation 1. So here we multiplied 1 by 12 and then we divided by 12 in order to become factor with x over 12. So after we multiplied 1 by 12, in total in the numerator we have here x plus 12 divided by 12 squared. Repeat again, in total in the expression here will be equal to x plus 12 over 12 squared times y squared plus x squared times r squared over 144, that is equal to r squared according to equation 1. So here we have the algebraic identity that a over b squared equals to a over b to the power of m, a over b to the power of m equals to a to the power of m over b to the power of m. Therefore, according to this algebraic identity, we will get that x plus 12 over 12 squared will be equal to x plus 12 squared over 12 squared, that is 144. So in total, x plus 12 over 12 squared will be equal to x plus 12 squared over 144 times y squared plus x squared times r squared over 144, that is equal to r squared. This is according to equation 1. In the next step, we join points A and C together by a straight line. What is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. In the next step, I copy this right angle triangle ABC in the new plane and implemented on this right angle ABC the Pythagoras theorem. So this is the right triangle ABC that I copied from the original drawing. Side AB and side BC, they are both equal to y because both sides are the sides of square ABCD, and we know that all the sides of square ABCD and they are equal to y according to our definition. And we just right now found out that AC, the product AC equals to R. In this right angle triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is Y, therefore BC squared is Y squared. So in total, according to equation 2, we found out that R squared equals to y squared plus y squared is 2y squared. So in total, according to equation 2, actually found out that r squared equals to 2y squared. This is according to equation 2. Read again. According to equation 2, r squared equals to 2y squared. Well, according to equation 1, we have already found out that r squared equals to x squared times r squared over 144 plus y squared times x plus 12 squared over 144. So here we have two equations. According to those two equations, we can substitute r squared in this equation 1 by 2y squared for this equation 2. Again, we can substitute r squared in this equation 1 by 2y squared from this equation 2. We actually did it and found out that according to equation 1, r squared is 2y squared, and it is equal to x squared times r squared. R squared is 2y squared over 144 plus y squared times x plus 12 squared over 144. Here we multiply this equation 1 by 144, and finally found out that 2y squared times 144 is 288y squared, and it is equals to here. After we multiply the equation by 144 in the denominator we get cancelled, and we left only with 2x squared times y squared, and here we have 144 in the denominator, so 144 in the denominator we get cancelled, and we left only with I squared times x plus 12 squared. Here we divided this equation 1 by y squared, and finally found out that 288 y squared over y squared is 288. 2x squared times y squared over y squared is 2x squared. And here y squared will get cancelled, and left only with x plus 12 squared. So according to equation 1, we actually found out that 288 equals to 2x squared plus x plus 12 squared. So 288 equals to 2x squared. We open the brackets of this expression, and x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is actually 24x. So we subtracted 288 from this equation 1, and found out that according to this equation 1, 288 plus 288 is 0, and here we have in the other side of the equation we have 3x squared plus 24x, and here after we subtracted 288 from this equation, so we have 144 minus 288 is minus 144. So in conclusion, according to equation 1, we actually found out that 0 equals to 3x squared plus 24x minus 144. Here we divided this quadratic equation 1 by 3, and finally found out that according to equation 1, 3x squared over 3 is x squared, and 24x over 3 is 8x, and minus 144 over 3 is minus 48, this is equals to 0. So here, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we can put the values of a, b, and c for our specific quadratic equation in this general formula for x, in order to find out the value or the values of x for our specific quadratic equation. We did it, and we found out that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a, so minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, and minus 4 times minus 48 is plus 192 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So inside the root we have 64 plus 192. So x equals to minus 8 plus minus, and 64 plus 192 is 256. So we have only 256 inside the root divided by 2. So x equals to minus 8 plus minus the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution, x equals to minus 12. But x can never be equal to minus 12 because of the fact that x is the length of this line segment GD, and x as a length must be a positive number. So we cancel the negative solution for x, and we left only with the positive solution. And the positive solution for x is as follows: x equals to minus 8 plus 16. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we found out that x That is the length of this line segment GD is equals to 4 units. I repeat again, the length of line segment GD is equal to X is equals to 4 units. Okay, thank you very much.